Good day, everyone. I am Miss CHRIZEL Alfeche, and I will be the one to discuss about number 11 problem set in our real analysis subject. This is the statement. Let A and B, a non-empty sets of real number, and let delta, or the distance between A and B, equal to the infimum of the set of the absolute difference of A and B such that A is an element of A and B is an element of B. The delta A and B is often called the distance between the sets A and B. Prove that the distance between the natural number and the real number over natural number is equal to 0. So by using the following hints, we're going to prove that the distance between the natural number and the set of real number over the natural number is equal to 0. So first, the corollary of the Archimedean principle. For every element E is greater than 0, there exists n, which is an element of n, such that 1 over n is less than E. Second, the characterization of the infimum. We have alpha, element of real number, is the infimum of a set, which is S, is a proper subset of real number if and only if alpha is a lower bound for S, and for every E greater than 0, there exists S element of S such that the alpha plus E is greater than S. If A is an element of N, then A minus 1 over N is not an element of N. What is the absolute difference of A and A minus 1 over N? So we are going to use the three hints in proving the that the distance between natural number and the real numbers over natural number is 0. Now, let's prove it. Let S equal to the absolute difference of A and B, such that A is an element of N and B is an element of R over N. We need to prove that the infimum of S is equal to 0. Since S is equal to the absolute difference rather, of A and B such that A is an element of N and B is an element of R of N, we can say that the element X of S must be greater than 0 and less than or equal to P, where P is greater than 0. Now, let P greater than 0. By the corollary of the Archimedean principle, state that for P, which is greater than 0, there exists N, which is an element of natural number, such that 1 over N is greater than 0 and less than P. If A is an element of N, then A minus 1 over N is not an element of N. So, A minus 1 over N is in R over N. If the absolute difference of A and A minus 1 over N is in S, then by getting the absolute difference, we have 1 over N, which is in S, and it is also less than P. So, P cannot be a lower bound. Thus, P cannot be a lower bound of S. By the definition of lower bound, then the lower bound must be 0 and less than 0. Then, by the characterization of the infimum of the greatest lower bound must be 0. Thus, infimum S is equal to 0. Yay! We have proved that the distance between the natural number and real number over natural number, which is equal to the infimum of the set of the absolute difference of A and B, such that A is an element of n and B is an element of R over n, is equal to 0. Good job! That's all. Thank you. God bless and keep safe, everyone. Bye-bye.